Okay, welcome to the second part of this video on solving systems of equations. In the last video we talked about the introduction and we presented the substitution method, and that was one way to combine the two equations so that we could get a single equation that has only one of the variables so we can solve, right? We have a second way called elimination method, and that's what we're going to talk about here. So just to see at a simple example of this, one way to combine the equations is to solve for one variable and substitute for the other. Right, we did that in the last video, but the other way to combine the two equations is we can simply add the two equations together to get a new equation. Let's try that with this system. Y equals x plus 1, y equals negative x plus 3. If I add these two equations together, I have 2y on this side, but x plus negative x cancels to 0, and then 1 plus negative 3 is negative 2, and so I've got a combined equation, and the x's happen to be eliminated when I added these two together. And so I can now solve for y and get y as negative 1. And then to get the x part of the solution, I can use either of the other equations, but this time I need to substitute that negative 1 in for y. And so negative 1 equals x plus 1, so if I subtract 1 from both sides, I'm going to have x is negative 2. Okay, and so I was able to get the combined equation by adding them, and the result was that the x's became eliminated, and so that's why this is called the elimination method. You eliminate one of the variables by adding the two equations. Okay, let's try that with another system. Here's a system. Negative 3x plus y equals negative 3, and negative 3x plus 2y equals negative 3. Let's just try to add the equations right now and see what we get. We have negative 3x plus negative 3x is negative 6x's, y plus 2y is 3y's, and negative 3 plus negative 3 is negative 6. Wait a second, when I added them, they didn't combine in such a way that one of the variables was eliminated, right? So in general, we might have to do something before we add the equations because these ones didn't cancel out, right? Okay, so what you need to do then in the elimination method, you have to pick one of the equations variables to eliminate. I think what I'm going to do is I'm going to eliminate the y's, okay? And so what I see is I've got 2y down here, right? I'm going to need in this equation for that to be a negative 2y, so that when I add them, they cancel to 0 and leave only x's. Okay, but right now, I don't have a negative 2y. I could get a negative 2y by multiplying the entire top equation by negative 2, right? It's okay if I multiply the left-hand side and the right-hand side by 2. Okay, and so I'm going to use this notation. What I'm really saying is I'm going to multiply the entire left side by 2, and I'm going to multiply the entire right side by negative 2, sorry. But I'm not going to write it that way. Instead, I'm going to use something that's just a little simpler. I'm going to show it this way. I'm going to say, put a parentheses around the entire thing and indicate that I'm multiplying the whole thing by negative 2. But hopefully it's understood that I'm multiplying the left and the right-hand side separately. All right, so let me do that and get another version of this top equation. I have to distribute this negative 2, right? So I have negative 2 times negative 3x is positive 6x. Negative 2 times y is negative 2y, and negative 2 times negative 3 is a positive 6. And my other equation I didn't change, right? So it is still negative 3x plus 2y equals negative 3. Okay, but now when I add the equations, right, they've been arranged so that the y's will be eliminated when they add together to 0. So I have 6x minus 3x is 3x equals 6 minus 3 is 3. I have a combined equation with only x's, which means I can solve, and x is 1. So I have the x portion of my solution. And then to find the y portion, I can substitute into either version of the equation. So I'll substitute 1 into that first equation. And then I'll solve for y by adding 3 to both sides and getting y equals 0. Y could certainly be 0. There's nothing wrong with getting 0. And there's nothing wrong with getting fractions in these problems either. But 1 comma 0 happens to be the correct solution here. All right. So sometimes you can force them to eliminate by multiplying one of the equations by a constant first, like this. Okay. Sometimes even more complicated. Maybe we have to multiply both equations by a constant. And here's a great way that works nicely. What you can do is just say, let's, for example, let's make the x's cancel this time. We've been canceling y's, but why not cancel x's? It doesn't matter which one. Let's see. If I were to take the top equation and multiply by a 2, and the bottom equation and multiply by a 3, and see what I'm doing? I'm multiplying by the number in the other equation, so that when I multiply I would have 6x's in the first equation and 6x's in the second equation. But when I add them, I want them to cancel, so I need to make one of them negative. If it's not already, they're not already, one's positive and one's negative. All right, let me write the equations over again. Distributing the 2 on the top, I have 6x plus 10y equals 2. And distributing the negative 3 on the bottom, I have negative 6x plus 6y equals negative 18. All right. Now when I add the modified system here, the x's are eliminated, and I have 16y's equals negative 16 when I add the numbers. And now I have an equation with only y's, so I can solve that and get that y is negative 1. So that's the y portion. And then I can back substitute into any of the other equations to solve for the x. So I'll go ahead and put in a negative 1 in for that y. I have 2x plus 2 equals 6, because it's a negative 2 times a negative 1, so it's a positive 2. And then if I subtract a 2 here, I'm going to have 2x on the left and 4 on the right. And I could continue to solve until I get 2 for x. So my solution is 2 comma negative 1. X is 2, y is negative 1. All right, so if you believe you understood that, try this one. This is our last example. Yeah, this is our last example. So pause the video, give it a try, and then unpause and see if you got it correct. Okay, welcome back. Here's what we would do. It doesn't matter which one you solve for. I'm going to solve for x's, and only because the numbers are a little smaller. I'm going to eliminate the x's, but you could have certainly done this with y. You should get the same answer either way. Okay, so if I do this to eliminate x's, I multiply this equation by a 3, and this equation by a 4, and make that one negative. And so if I multiply these out, I get 12x minus 21y equals 6. And then I would have negative 12x plus 12y equals negative 24 when I distribute the negative 4 there. And when I add, the x's would be eliminated. Then I'd have negative 9y equals negative 18, right? And then if I divide both sides by negative 9, I would have y equals 2. Whether you did the x's to cancel or the y's, you should still have in your final solution y is 2. Okay, I'm going to use the second equation to back substitute the y in to get the x. So 3x minus 3 times 2 for y. 3x minus 6 equals 6. Add 6 to both sides. And then 3x equals 12. So x equals 4. So it looks like the correct solution here is 4 comma 2. All right, and that's the elimination method. So when you combine it with substitution method, there's 2 ways that you can use to solve for a system. Okay, quick summary of the elimination method, right? You want to multiply all the terms of one or both equations by whatever numbers you need to choose, so that when the equations are added, one or the other variable is eliminated. Then you add the equations, and then you solve the resulting combined equation. You can then substitute your resulting x or y value into any of the given equations to find the remaining variable. Now there are some special cases that can happen with lines. You can have parallel lines, you can have coinciding lines where there's no solution or there's infinite many solutions. That may come about in the practice problems. If you want more information about that, you should watch the video on parallel perpendicular intersecting lines, because that'll go into more information about why you might have special cases here. This one's just to present the different methods for solving. Okay, thanks.